recording. Just a quick announcement is that next week we don't have class. Next week will be our Raya break, which is between 11th to the 17th of March, May. So we'll basically stop for a week for Raya. After that, we're all going to resume back class the following week. So next week, y'all can rest. Okay. I will be printing out the next chapter soon. I'll let you guys know when to go and collect. Then y'all can go and collect. All right. All right, let's go on to the questions. Now, anytime you've got any question you want to ask, you can always ask me. If you want to privately message me through direct chat, you can send it to Walter number 2, so that I'll be able to see it, because I'm using my tablet to teach, so I won't be able to see your message through the main chat, right? So be sure to direct your message to Walter number 2, and I'll be able to see it. I'll answer your question. All right, let's look at the first one. Basics of compound formation. Let's go to the first one. Magnesium has an electron arrangement of 282, which is following true about magnesium. So it says over here, among all this, which is true. So magnesium shares, you can see the word share, right? So automatically when you see the word share like this, means it's wrong. Magnesium will never share electrons because it is a metal. So therefore it must be a donator of electrons. So it must donate or release, or even to lose 2 electrons. You see in B over here, it says here magnesium loses 2 valence of electrons. So this is actually correct. So the rest of it should be wrong. So let's see C and C. Magnesium already formed a duplet, so it is not a duplet. So this is definitely wrong. Magnesium receives 6 electrons. So we see here receives. Metals don't receive electrons because they are electropositive, not electronegative. So therefore, this is also wrong. That's why the answer is B. All right, number 2, which of the following is not true about noble gases? So it says here, not true. Please be very careful when it comes to this kind of question. Sometimes we may overlook the word not, and then we won't answer the correct answer, and it's actually wrong already. Okay, so here, noble gases are non-metals. This is actually true, so therefore this is not the answer. Noble gases are monoatomic gases. This is also true, so that's not the answer. Noble gases are chemically unreactive. This is also true, so not the answer. Last one, noble gases form covalent compounds. So this is actually false, right? They don't form any compounds because they cannot react with anything else. So therefore, the answer is donkey. Table 1 shows, table 1 gives the proton number of element W, X, Y, and Z. Which of the following are likely to form ionic bonds? So we know that ionic bonding exists between a metal and a non-metal when electrons are being transferred from one atom to another. Okay, so how do we do this question? It's very easy. Look at this. They give you the proton number. So most likely they want you to find out and see what is the electron arrangement, and to find out what is the valence electron for each and every element here. So if you recall back last time in the periodic table of elements, proton number refers to basically the number of electrons as well. So in this case, you can see over here, there are 6 electrons in proton, 10 electrons in X. Sorry, 6 electron in W, 10 electron in X, 17 electrons in Y, and 19 electrons in Z. So you can actually write out the electron configuration. So in this case, this will be 2, 4. This will be 2, 8, 2. This will be 2, 8, 7. And this will be 2, 8, 8, 1. Okay. So we see over here, which of the following combination can form ionic compounds, right? So I would say an ionic compound can be formed between either X and Y, or Z and Y. Okay, both can, because they are both metals. So either X and Y, or Y plus Z. So the only answer that's possible here is basically C, okay, Y and Z, right? Yeah, say Y and Z. There's no X and Y here. Yeah, there's no X and Y here, so that's not answer. All right. So remember, ionic compounds can be formed only between a metal or non-metal, and they involve transfer of electrons. Number 4, an element X forms an ionic compound with oxygen with the formula X2O3. What is X? So you can see over here, X2O3 means that technically when you have to swap the numbers away. So I would say that originally X could be 3 plus and O can be 2 minus law. That's why they swap number, am I right? They swap the number already. What happens is that they will have their own respective numbers. So they'll be like this instead. So it will be a group 13 element. And among all of these, there's only one group 13 element. The answer is aluminum. Okay. Number 5, which of the following is an ionic compound? So we always tell you that ionic compounds are basically compounds which contain a metal and a non-metal. So definitely not A because there's 2 non-metals. Definitely not B as well because there's also 2 non-metals. Definitely not C as well because there's 2 non-metals. And the answer is donkey. All right. So because it's aluminum oxide, it's a metal and a non-metal. All right, let's look into covalent bonding. Why does carbon dioxide have low melting point? So if you recall back what I explained to you last time, carbon dioxide has a low melting point because of its weak intermolecular forces, right? So do we break the covalent bond? The answer is no, right? Always remember that we don't break the covalent bonds unless it is between a giant molecular structure. So this is not. Carbon dioxide is actually a very simple molecule. It has very weak intermolecular force between them. So the best answer to answer this is basically boy. The intermolecular forces between carbon dioxide molecules are weak. Number 7. Wait, a lot of them. Right, sorry. Right. Number 7, which of the following is not true about nitrogen molecules? So again, not true. See properly. So each nitrogen atom contributes 3 electrons from the outermost shell. Okay. So you see over here, we know that nitrogen itself is in group 15. So therefore, nitrogen itself has 5 valence electrons. Okay. So I would say, if you were to show only the valence shell, right, you will only have 5 valence electron, which means now nitrogen technically has a lack of 3 more electrons to achieve octet stable electron configuration. Okay, so each nitrogen atom contributes 3 electrons from the outermost shell for sharing. This is actually true, right? So definitely not answer. B, 3 single covalent bonds are formed in nitrogen molecules. That's actually possible. So I will basically say that this is actually technically correct. Each nitrogen atom achieves an electron arrangement of 2-8 after sharing the electrons. So we know that nitrogen is basically N is 14, 7, right? So we have an electron arrangement of 2-5. So after receiving or after sharing 3 electrons, it should have a stable electron arrangement of 2-8. Right, and then D, 6 pairs of electrons are involved in forming the bond of nitrogen molecule. So nitrogen molecule is formed when 2 nitrogen atoms come side by side and they share actually 3 pairs of electrons. Total of 6 electrons, yes, but they are sharing 3 pairs of electrons. When they say share 6 pairs of electrons, it's 6 times 2, which is technically 12 electrons in total sharing. Do they even have that much of electrons? No, they don't, right? So I would say that D is wrong because it's definitely not 6 pairs of electrons. That's a total of 12 electrons. That's crazy. So I would say that D is actually not the answer, but this is what they want, right? Not true. So the answer is donkey. Right, number 8. Table 2 shows the information about 5 elements. We got P, Q, R, S, and T. 2.4, 281, 283, 286, and 287. Each element in the table 2 can react with each other, which pair of elements forms a compound that is insoluble in water. Okay, let's look at this. Now, insoluble in water means they cannot dissolve in water. Okay, so we're going to see what kind of compounds cannot dissolve in water. Now, most ionic compounds can dissolve in water. Only only non-metals, covalent compounds, they cannot dissolve in water. But not all, like I said before, there are some exceptions to it. Like, for example, hydrogen chloride can dissolve in water to produce hydrochloric acid. So that's another example there. Right, now let's look at this. So which pair you can see over here? Let's just look at the first one, QT. So Q and T is basically an ionic compound, right? Because what they want is actually insoluble in water. So Q and T forms an ionic compound. So normally ionic compound can dissolve in water. So I would say this is not the answer. Right? R2S3. So R2 and S3 basically forms another ionic compound as well. You can see over here, this is actually a group 13 metal, and this is a group 16 non-metal. So therefore, this is also an ionic compound. So technically speaking, it is not the answer. PS2, let's look at PS2. P is technically 2, 4, and S is actually 2, 6. So they're basically non-metal. Do you see that? So P and S, they're actually non-metal. So I would say this is actually a covalent compound. This might be the answer. I'm going to keep it there first. Let's look at RT3. R, again, is a metal, and T3, T is a non-metal. So again, this is actually an ionic compound. So most likely it is able to dissolve in water. So therefore, that's not answer. So yeah, correct. C is the answer, because why? This is the only ionic compound. Sorry, this is the only covalent compound that we have among all 4 options. Okay. So the one is insoluble in water. So if it's insoluble in water, it's usually soluble in organic solvents. Okay, organic solvents, for examples, like maybe ethyl acetate, methyl benzene, and so on. Okay, like I gave before. Hydrogen bonding. So then number 9, in which process the hydrogen bond has broken? So you see over here. Remember, hydrogen bond is between H and fluorine, oxygen, and nitrogen only. Yeah? So we see over here. I would say that this is not, because it has to be hydrogen and FOON. So A is definitely out. B is possible because it has hydrogen and another nitrogen, right? You can see over here there's a NH3 has 2 different atoms. So we have hydrogen and we have nitrogen. So that could possibility where you could actually form hydrogen bond. So I'm just going to keep it here first. Between H and I, it doesn't fall under this category here, so that's definitely not the answer. Methane to form carbon and hydrogen. I also don't think there's any kind of hydrogen bonding because there's no F or N. So yes, the answer is boil. Okay. Okay, next. Number 10. Ammonia in water consists of ammonia and ammonia and water molecules, as well as ammonium and hydroxide ions. What are the chemical bonds present in the ammonia solution? So I would say you will have ammonia and water molecules. So definitely you'll have covalent. All right. And then do understand that when you mix ammonia and water, they do produce ammonium ion and hydroxide ion. So you'll definitely have dative bonding. So if you recall back, do you remember what dative bonding is? Dative bonding is when there is a type of covalent bond when one of the atoms actually share 2 electrons straight away with another atom, right? And one example is actually ammonium ion. Okay, so if you recall back, ammonium ion, basically, like I told you before, right? Ammonia itself, the nitrogen basically shares one valence electron each with hydrogen atoms, but there is actually an unpaired electron, all right, which is called a lone pair, remember? So this lone pair can then be sort of like shared with another empty shell hydrogen ion. In this case, remember to do that. because hydrogen ion itself basically has no more electron. So the empty shell can actually occupy and share this electron with nitrogen. So therefore, after that, what you'll have is basically this. Okay. So we have this kind of symbol. And then the whole thing becomes positively charged. Okay. So that's called dative bonding. And then let's see the next part over here. Do they have anything else? Do they have ionic bond? So technically speaking, if you do dehydrate it, you will be able to form ammonium. No, do they have ionic bond? Let me see. No, I don't think they have ionic bond in this case. So do they have hydrogen bonding? Yes, between ammonia and water, they can have hydrogen bonding. Between ammonia also can have hydrogen bonding. So water molecules can have hydrogen bonding. So definitely got hydrogen bonding. So I'm gonna put here as H bond. What else? There is a possibility where the ammonium ion and the hydroxide ions can attract each other. So that's called electrostatic force, right? So I would say the best answer here will be donkey. It has dative, it has hydrogen, it has covalent, and it has electrostatic force. So all four together. Do you understand? You need any help to understand this part? Or if you have any question, you can just ask. Like, we don't understand why, things like that. But you want me to explain further because you don't understand, just let me know, yeah? No? Okay. All right. 11. Which of the following atoms can cause hydrogen to be attracted to form hydrogen bonding? So you can see over here, remember I told you many times, right? Which of the following atoms can cause hydrogen to be attracted to it to form co-hydrogen bonding? So again, H towards either F, O, or N. So in this case, it will be hydrogen towards fluorine, oxygen, and nitrogen. So we saw that the other three is not possible, only fluorine is. So the answer is fluorine. Okay. Now, remember, the reason why hydrogen can form this hydrogen bonding with these three different elements, which is fluorine, oxygen, and nitrogen, is because of its very electronegative nature. Okay, I'm talking about the electronegative nature of fluorine, oxygen, and nitrogen. And because they're electronegative, they tend to pull the electrons closer to themselves, causing the hydrogen bonding to exist. So that's why it can only form between hydrogen and also fluorine, oxygen, and nitrogen. Number 12, arrange the following substances in ascending order of their boiling point. So I'll say that among all this, right, technically, fluorine itself will have the highest. Never check and see. Let me recall back. Yes, no. Ammonia is stronger. Nitrogen is stronger. Okay. How about this? I give you the value of it. That'd be easier for you. So let's just look up the value. So technically, it's not written in your book, but let me just explain it to you. So let's just look at the electronegativity of nitrogen. Nitrogen. Okay, so nitrogen is 3.04. And then let's see oxygen, and then let's see fluorine. 3.98. And then last one is oxygen. 3.44. Okay. How do we remember that compounds have dative bonds? Okay. So there's two requirements to have dative bonding. Number one is, like I said before, to form a dative bond between two atoms, you must make sure that one atom must have a lone pair of electrons. A lone pair means there's an unpaired electron. And the second one, it must have an empty shell. That's the two criteria. If it's an ion, it will normally be hydrogen, because hydrogen has an empty shell. Hydrogen ion has an empty shell. So you can accommodate the two electrons. That's how we know. Okay, two main criteria. How to know which atom can form dative bonding? Number one, one of the atom must have a lone pair, which is an unpaired electron. And another one is that it will have empty shell to receive the electron. That's it. That's the criteria, basically. All right. In terms of electronegativity, right? In this case, you can see I gave you the value of electronegativity here. The reason why I give this value is because you need to know how to compare. All right, you need to know how to compare. We can't just say, for example, chin-chai lah, all three also electronegative, chin-chai tembak lah, cannot. Okay, must understand why. So let's look at the question in the previous page first. It says here, arrange the following substances in ascending order of boiling point. Okay, when you talk about ascending order of boiling point, right, it means they're talking about the hydrogen bond's strength. Not necessarily hydrogen bond, like could be also van der Waals, could be dative bonding, doesn't matter. But of course, obviously, you can see over here, right? They got fluorine, they got oxygen, and they got nitrogen over here. So we are definitely comparing the hydrogen bond strength among all these three molecules. Okay, so to see which one has the lowest and which one the highest law. So in terms of electronegativity, right, I would say the lowest electronegativity will be nitrogen, followed by fluorine, and then finally oxygen. So before I go on to the answer, if you don't remember what electronegativity means the tendency of the particular element to accept electrons or to attract electrons. Okay, so the higher the value of its electronegativity, the higher the number. You understand? One more time, the higher the electronegativity number, the more electronegative it is. So that's why I put a sequence over here, like N and then F and then O. Okay, so if you see based on these three diagrams here, right, then you'll be able to roughly tell what's the answer, right? Obviously, you can see over here, nitrogen is the weakest, so you'll start first. So NH3 will be the lowest law. So it could be A, B, or D. Then the second one will be fluorine, so it must be a HF. So technically here will be HF will be second one. And the third one will be water, which is 3.98 lah, with oxygen. So if you see here, there's actually two answers, either A or D, they're the same thing. Okay, so I would say that either A or D lah, they're the same answer. So you can pick one of it. When we talk about electronegativity, it depends on several factors also. Not necessarily the size, not necessarily the reactivity. In terms of reactivity, yes, I would say that fluorine itself, it's very reactive compared to oxygen because it has only one more valence electron to fill, right? To achieve octet. That's the logic behind it, correct? But when it comes to the ability to attract electrons, there's a lot of factors involved. It depends on the repulsion of electron inside the atom. It also depends on the pulling force of the nucleus towards the atom itself. The pulling force of the nucleus towards the electrons itself. So when you go up to STPM level, then you'll be able to understand, or A levels, then they'll teach you how to see repulsion between electrons and how well the nucleus can attract the electrons and things like that. Okay, so technically speaking here, right, you can see oxygen is among the highest electronegativity among all three elements there, due to its ability to attract electrons into its own valence shell. Right, so since it has the highest electronegativity, therefore it has the strongest hydrogen bond. So the answer is either A or donkey lah. Okay. Number 13, which of the following contains a dative bond? So again, like I showed just now, dative bonding is when you have a lone pair of electrons and you also have an empty shell to receive the electrons. So I would say the answer is C, ammonia. The rest is not. Huh? So which of the following is true about, sorry, not true about dative bond, right? So here you can see here, dative bond is a covalent bond. Although it is technically a type, I mean, it is lah, basically, because it's still sharing electrons, right? So this is correct. But they want not true, so that's not answer. Dative bond forms electrostatic force between ions. That could be a case because, like I said just now, you could have an ion interacting with a molecule, for example. So I would say that it could happen. So this is also considered correct. Donating a pair of electrons from an atom, this is true. Donating a pair, but it's actually sharing. So I don't know why they use the word donating. It's supposed to be sharing, but yeah, it's okay. Okay, so donating a pair or sharing a pair of electron with from an atom, so this is actually correct. Sharing a single pair of electrons to form from a single atom, this is wrong. This is normal covalent bond. So D is the answer. It is not the answer. Okay, D is the answer. All right, 15. Which statement is true about metallic bonding? So let's look at the answer. A bond that's formed between positively charged metals. Not so accurate, huh? Like I said before, right? If you have like a positive and positive, they will not attract each other, they repel instead. But because, like I said, there are electrons in between them, a mobile sea of electrons, so therefore they are attracted to the electron instead, not true by themselves. So A is definitely out. Let's look at the other one. A bond is formed between nucleus of a metal atom and the valence electron of its atom only. So you can see here a bond that is formed between the nucleus of metal atom and the valence electron of its atom only. This is wrong. Wait, is it? Bond is formed in the nucleus between atom and the valence electron of its atom only. Actually can. I would say that what he's trying to say here is basically its bond is formed between nucleus and the electrons. Okay, just focus on the word nucleus and the electrons, which is true lah. We know that the electron can move throughout the whole structure of the metal, yes, indeed. But there will always be electrons around them and causing the metal ions to be sort of like strongly attached to each other in a way. So I would say B is still correct. C, the valence electrons of metal atoms are delocalized to form the C electron. So the word delocalized here is correct. So I'll say this is correct. Now we see donkey, right? The valence electron of metal atoms are localized in the sea of electron. What does it mean? The word localized means the electron is stationary at one position. So I would say this is wrong, right now. This is definitely wrong. Oh, they want true. Let me see. So C is the answer, technically, right? This is wrong, actually. Why wrong? Oh, there's a word only, that's why. Okay, so remember I told you before about metallic bonding. Actually, right, the electrons, the valence electrons are free to move around the whole structure. So I didn't notice this word only just now. So when you say only means the valence electron will move around the same nucleus. So this the same atom itself. So I don't think it's correct. Your electrons can move anywhere. The electrons, like I said before, doesn't belong to anyone. It just moves throughout the whole structure. So the word only here is actually wrong. Right? So the rest of it is also wrong. So only one correct answer, which is C. 16, which one of the properties is due to the C of delocalized electron in metallic bonding? So this is actually very important. All right, if you have a delocalized electron, a C of delocalized electron, it means that metals can conduct electricity in a solid state. So the best answer to describe the situation will be C. Okay, the ability to conduct electricity in a solid state and also in a molten state. Molten means melted, okay, in a liquid form. So it can be in a solid and also in a molten liquid state. All right, next 17. Compound Z conducts electricity in a solid or molten state. It also has a high melting point and boiling point. What is that? So the moment you see, right, it conducts electricity in a solid state, it must be metal already. It cannot be an ionic compound already. Why? Like I said before, ionic compound, right, they have ions, but in a solid state, they cannot move. Right? If you remember, right, any ionic compounds that you have, they are alternating positive, negative, like that, right? So they can't really move per se, is because they are tightly bound together in an alternative form, right? So in order for you to let them move and carry electrical charges, they have to be melted down. So ionic compounds do not conduct electricity in a solid state. So among all of you can see over here, there's only one which is metal alone. So the answer is 1. Why is question 14D? Where is it? Because it's not true. So the rest are all correct except for donkey. It says sharing a pair of electrons from a single atom. Oh yeah, it's correct, right? Sharing a pair of electrons from a single atom. Oh yeah, then C is wrong actually. Oh, okay, correct. So yeah, swap please, change please, my bad. The answer is C, not true. This is correct actually. Sharing a pair of electrons from a single atom, yeah, correct. So one atom donates it out. No, one atom shares a pair of electrons, correct. Not donating. Donating is like I give you away, go away. That kind of thing. No, but it's together. So they are actually sharing. So yep, correct. So the answer is C. Thank you. So please change the answer. 14 is C. Let's go 18. Which of the following describes the arrangement of particles in a metal? So closely packed electron with delocalized ions, terbalik, wrong. Why? It's supposed to be closely packed ions with delocalized electrons. So this is actually wrong. B, alternating layers of metal and electrons. Technically, it can happen, right? But we'll see what else there's. Layers of metal ions and electrons, no. Okay, then I think the best answer will be donkey. Why? Because you see, there are layers of metal ions, surrounded by delocalized electrons. So remember, I showed you the structure last time. I did draw this before at the bottom here. You have a lot of ions basically stacked together in layers, right? Like I said before, they're all positively charged. And then there's electrons moving around. So these electrons are delocalized, so they move throughout whole layers. So this perfectly describes the situation in metallic bonding. So 18 is donkey. Right, diagram 1 shows the electron arrangement of a compound formed by transferring of electrons. So you have X2 plus and Y2 minus. Which compound is formed through the same method as the compound in diagram 1? So it's definitely not turpentine, not vinegar, not glucose, but it is rust. I'll explain to you why. Because turpentine, there's no ions. Vinegar, there's ions, but it is dissolved in water. Glucose, okay, turpentine and glucose, no ions. So it cannot be A and C. Between B and D, they both have ions, but vinegar itself produces hydrogen ions and ethanoic ions. So I wouldn't say this is actually correct. So B is definitely out. If you want the formula, if you want to know the explanation of why vinegar is not an answer, vinegar contains ions, by the way, because vinegar is actually ethanoic acid. So next time when you learn about acid and bases, you will see that acids can dissolve in water to produce ions. So in this case, right, the equation is this: CH3 COOH, reversible arrow, H2O, and then you have CH3COO minus plus H plus. So when they dissociate to produce ions, in this case, you can see that they basically have a negative 1 charge and a positive 2 charge. Positive 1 charge. So this is actually a +2 plus and -2 minus. So that's not an answer. And also the fact that you can see, right, ethanoic ion got so many atoms inside. So how can that be just in one, for example, right? So definitely wrong. So vinegar is out. If you want to know, another name for vinegar is actually ethanoic acid. There is another name for it also called acetic acid also, right? So those are the common names for ethanoic acid. So the answer is rust. So what's rust? Rust is actually hydrated iron oxide. Okay, so it'll be hydrated iron 3 oxide. So it'll be Fe2O3 dot XH2O. Okay, X could be a number lah, 3, 5, and so on. So this is the ionic compound actually. So the answer is donkey. You understand, right? If you don't understand, let me know so I can explain to you. All right. 20. The periodic table of elements in diagram 2 shows the position of elements U, V, W, X, and Y. Which of the following are true about elements shown in periodic table? So you can see over here, we have ionic compound, covalent compounds. So let's see. UY is group 1 and group 17. So that is ionic, correct? It's a covalent compound between W and Y4. So W is actually in group 14. And with Y, it could form Y4. This is correct. Possible, Possible, because W has 4 valence electrons. So it can share with another 4 Y atoms. So that's correct. B, UX2. U and X2 is U2X, I think. U2X. Yeah, it's U2X, not UX2. So this is actually out. W and Y. W and Y. So this is correct. UY. UY is also UY is okay. This is wrong because Y. This is covalent ma. This is ionic. So this is terbalik already. So wrong dia. UY is ionic. WY4 is covalent. So C is wrong. Donkey, Y2 is correct, but it's not ionic, so it's wrong. UX4 also wrong, so technically only got one answer lah, A. Why does vinegar and others not have ions? Vinegar got ions, but it is not XY2. Sorry, it is not X and Y. I explained to you because you can see over here, right? Ethanoic ion has like 1, 2, 3, 4, 7 atoms inside. Do you see? 7 atoms inside combining together to form one ion. So it doesn't make sense if it were to be this one, right? This is only one single atom, so definitely wrong already. The rest is not. Turpentine and glucose, they are covalent compounds. They don't have ions. So that's why A and C is also out. That's how we tell. Okay. Next, 21. Table 3 shows the proton number of elements P and Q. We have a 281 and 26 over here. Which of the following shows the electron arrangement of compound formed when element P reacts with element Q? So technically speaking, 2 of P must donate electron to Q so that they can form a compound called P2Q. So the best answer will be C, right? Because you need twice of P and 1 of Q. I know this is X and Y. Supposedly the inside here should be P and Q, but it's okay. Just ignore it. We know that is the answer. Because for every one Q, you need 2 P's to donate 1 electron each. Then they will achieve octet. All right, 22, diagram 3 shows the symbols for 2 elements, S and T. The alphabets used are not actual symbol of the element. So we have S and T here. So we have proton number 12 and proton number 8. So S and T react to form a compound ST. Which of the following is true about S and T? So let's see first. 12 means 282. 8 means 26. So when they form a compound, they should be ST, correct? But they must be an ion, where S and T means S is 2 plus, T is 2 minus. Right? So in this case, I will say that ionic compound. So does it dissolve in organic solvent ionic compound? The answer is no. It dissolves in water mostly. Does not conduct electricity in a solid and molten states? Wrong. It does not conduct electricity in solid, yes, but in a molten state it can. So B is also wrong. C has high melting and boiling point. This is actually correct. Ionic compounds are solids at room temperature, so you must have high melting and boiling point. So C is the answer. D exists as glue gas in room temperature. No, it is a solid at room temperature. Right. 23. The following are properties of compound X. Has high melting point and boiling point, conducts electricity in aqueous solution or molten state. Dissolve in water but does not dissolve in organic solvent. So we know this is for sure ionic compound already. Okay. The moment you see can conduct electricity in aqueous solution or molten state, confirm it is a ionic compound already. So which of the following is substance X? So glucose is not, because glucose is a molecule, a covalent compound. Okay. And then we have tetrachloromethane. Tetrachloromethane is CCl4, also not, because it is a covalent compound. Naphthalene is C10H8. Sorry, C10H8, correct. So this is also a covalent compound. Salt, yes. Salt is actually made out of ions. So donkey is the best answer. So the rest of it, naphthalene, tetrachloromethane, glucose, they are all basically, what do I say? They are all basically non-metals, covalent compounds. 24, table 4 shows the electrical conductivity of 4 substances P, Q, and R. You can see here, electrical conductivity will be solid state, molten state. P cannot conduct the electricity in both solid and molten state. So most likely P will be a covalent compound. And then Q can conduct in molten state, but not in solid state. So this is definitely ionic compound. And then R can conduct both in solid and molten state. So this is definitely a metal. Okay. So which of the following is most likely to be P, Q, and R substance? So like I said just now, P is covalent. So I'm going to take and assume that P is sulfur. So this is out. Second one, sodium is a metal, so it must be R. And last one, lead 2 bromide must be an ionic compound, which is Q. So the best answer will be 4. Okay, 25, which of the following is the property of ammonium sulfate? Does not conduct electricity in solid and aqueous state. Ammonium sulfate is an ionic compound. Huh? There's a formula of NH4 bracket 2 SO4. That is because ammonia is plus, SO4 is 2 minus. That's fine. Okay. So does not conduct electricity in solid and aqueous state. This is wrong. High melting and boiling point, I would say yes, technically. Soluble in organic solvent, no. Insoluble in water, no. So the answer is boy. Okay, so yes, there you go. All the objective questions. Okay, so what I'm going to do now is that I'm going to let you flip back and see. All right, while I go to the toilet for a while. Flip back and see if you have any questions you want to ask me for the objective questions. All right, and then we'll continue the discussion for paper 2 afterwards. Okay, so we'll take a short break around a couple of minutes. So do flip back and see which question you want to ask me or you're not very familiar with. Maybe you think that you need more explanation on the answer. If you don't understand, do ask. Okay, and I'll explain to you if you need any explanation. All right, so we'll take a short break. Eh? Okay, guys, let's start. So, any question you want to ask for the objective questions? If not, then I'll move on to the next part with the questions. No, can I? Why is question 7A true? Let me see. Question 7A. Oh, yeah. So it says here, each nitrogen atom contributes 3 electrons from the outermost shell for sharing, correct? So in the nitrogen molecule, I told you just now, right? We got N triple covalent bond, right? So triple covalent bond means they share 3 electrons each. So you can see each contributes 3 electrons. So correct? Then they will form, so basically they're sharing 6 in total, 3 from each side. That's what it means. Yeah, that's why it's a triple covalent bond. Right? Any other questions before I move on to the next part? No? Okay. All right, let's go to the next part. Now let's go to paper 2. Section A. Table 1 shows the four symbols of four elements. Or four? 3 only. Okay, so we have magnesium, oxygen, and carbon. So based on table 1, choose one element that forms a negative ion. So obviously it's oxygen. No? Okay, so put there oxygen. Okay, oxygen is the answer. The rest are all. Magnesium is actually a positively charged ion. So O is O2 minus, Mg is Mg2 plus. For carbon, it's a bit hard to say. Carbon is plus minus 4. So why is it plus minus 4? It depends on what kind of atom it is bonded to. Right. So if you've got a chance, I'll show you some examples. Sometimes carbon can be positive, sometimes carbon can be negative. It depends on whether it is bonded to a more electronegative atom or a more electropositive atom. Okay. Which element forms metallic bonding? So obviously there's only one, which is magnesium. Okay. Explain about the metallic bonding using the answer from A2 as an example. So you can just say that there is an electrostatic interaction between there's an electrostatic attraction between the positively charged ions of the metals with the C of the localized electron. Okay, so I'm going to put it here. Electrostatic attraction between metals, metal ions, between the metal ions with a C of delocalized electron. Delocalized electron. So that's the metallic bonding. Okay. So if you were to say electrostatic attraction between electrostatic attraction, you 1 mark already between the metal ions and the C of the localized electrons will give you the second mark. So total 2 marks. All right. How can metals conduct electricity in a solid state? So you can just say that there are a sea of the localized electrons which are able to carry electrical charges. Okay, so you can say there is, write a big one. There is a sea of delocalized electron to carry electrical charges. Okay. Right. B, magnesium reacts with oxygen to form an ionic compound. Okay. So draw the electron arrangement of the ionic compound form. So don't have to draw the whole process. You don't have to draw like, okay, magnesium plus oxygen, you get what, and things like that. You just have to go straight to the point itself. Draw the product itself only. So which means over here, right, you just draw magnesium first. So magnesium after the reaction got technically 2 shells. So I'm going to use a circle. And bracket 2 plus. Okay. And then for oxygen will be also 2 shells. Okay, I'm going to use X. And this will be 2 minus. That is okay. Then you get 2 marks already. So this will be Mg2 plus, and this will be O2 minus. Okay, quickly draw that on first. Okay. Right. State one physical property of ionic compounds. So again, this is physical property, yeah. So you can just use very simple ones, like for example, high melting and boiling point, solid in room temperature. You can also say soluble in water. Those are considered as physical properties. So I give you a few. So we just use one now. The first one, which is the easiest one. They have, what's that called? High melting and boiling point, yes. Okay, and you can also say solid at room temperature. Conducts electricity at in molten state or aqueous solution. And then soluble in water, although not all. Okay, like I said before, most but not all. Right, so that's basically some of the examples I can give you. You can copy all this down, but I think just memorize the one you're comfortable with, I would say. Usually 1 mark only or 2 marks. So remember like 2, I would say 2 easy ones to remember. Then you can write down an exam. Okay, give one similarity and one difference in physical properties of metal and ionic compound. Give one similarity and one difference in physical properties of metal and ionic compound. So I would say one similarity between metal and ionic compound is that they have high melting and boiling point. Okay. So for similarity, I'll just mark it as S. High melting and boiling point. And then differences will be D. Differences will be, I would say that metals are not able to conduct, metals are able to conduct electricity in a solid state, but ionic compounds cannot. Okay, so that's the answer. Okay, next. Number 2, diagram 2 shows the electron arrangement of compound S formed when nitrogen reacts with hydrogen. Okay, state the type of bond in compound S. So this is technically ammonia. So state the type of bond in compound S, I would say that it is a covalent bond, okay? Because you can see that they are sharing electrons, right? So they're covalent compounds. So covalent bond. Write a chemical formula for compound S. So that would be NH3, which is ammonia, basically. Then let's look at the next one. Give 2 physical properties of compound S. So we know that ammonia is actually a gas at room temperature. The first one to put here is a gas at room temperature. And since this is actually a weak, I'll say simple covalent molecule, right? So you can just put there low melting and boiling point. Okay, you can include others like does not, you can say does not conduct electricity, in, I would say poor conductor of electricity and heat also can. You can also state that it is actually dull in terms of appearance. For ammonia, it smells pungent. So if you want to add that in if you want to, no problem. But be very careful if you were to write in terms of solubility. Now, ammonia itself is soluble in water, yeah? So if you were to write solubility, sometimes students get this mistake as in they thought that ammonia can dissolve in water, but actually can. So if you write ammonia is insoluble in water, although we know that a lot of covalent compounds are insoluble in water, ammonia itself can solubilize in water. So if you write there insoluble in water, it's wrong already. Okay, so be very careful with that. Some covalent compounds can actually some covalent compounds can actually dissolve in water. If you want the equation, I'll give it as well. The equation is this: NH3 can dissolve in water to produce, let's put here, NH3 plus H2O, reversible arrow, you get NH4 plus OH minus. So that's the equation if you want to know lah, whether it is soluble in water or not. So yes, ammonia is soluble in water. It produces an alkaline solution. All right, let's look at the next one. Compound S exists as a gas. What is the force of attraction between the compound S molecules? So you see here, they want to know the force of attraction between the molecules. So we're talking about not about the covalent bonding. We're talking about the intermolecular force that exists between them. Okay, now let me ask you, what do you think the answer is if I want a specific answer? Right? Like if let's just say I don't want to use intermolecular force, I can just put that intermolecular force. But what is the specific answer for this kind of question? Can someone tell me that? Now, in this case, I cannot write intermolecular force because if we look into that, right, they want a very specific answer. All right, you can see here what kind or what type of force of attraction between compound S molecules. So we can't put that intermolecular force. Although that's technically the general term of it, yes. Like I always tell you, if you write in sentences in essay form, you can mention intermolecular force, but in this case, they want you to say the specific type. So what are the two specific types of intermolecular force that I've taught you just recently? You want to recall back? Can you just throw me some random answers and tell you what's correct or wrong? Anyone? Okay, so you have mentioned one. Okay, what else besides that? Anyone else want to try? So, okay, so what you said van der Waals, right? Actually, correct. One will assume is van der Waals, but in this case, if you notice, right, talking about ammonia. So if you realize it's not ammonia, we actually have something called, we have hydrogen and we have nitrogen. So if I were to have another hydrogen attracted to that, for example, then this bond here is called what? This is actually hydrogen bonding. Do you see that? So yeah, that was what I wanted you to try and see, because I want you all to differentiate between van der Waals forces as well as hydrogen bonding. So in this case, right, this is actually hydrogen bonding, not van der Waals forces. But good try. Okay, I want you all to try. I want you all to know that, you know, there are several answers to this. At least if you get it, if you get it wrong also, it's okay, because why? At least now you understand how it works. Okay, so van der Waals is only for anything that is not between H, right? Anything that's not between H and F, O, or N. All right, so in this case, you can see, right, H and N exists here, so this hydrogen bonding. So I would say that this is actually hydrogen bond. All right, but good try, good try. Right, so do remember to check properly and see whether there is a possibility where you can form hydrogen bond or not. If there is no formation of hydrogen bond, then go ahead, right? Van der Waals forces is fine. Not necessarily. Good point. Not all that involves hydrogen bonding. It must be between hydrogen and also the three elements here. You see it? So I say handphone, remember? So either hydrogen with fluorine or hydrogen with oxygen or hydrogen with nitrogen. All right? Not others. Like hydrogen with chlorine, I think. Hydrogen with iodine, I think. It must be between hydrogen and F, O, or N. And in this case, you can see, right? There is a hydrogen and N here, right? See properly, yeah? There is a bond between them here. So this is what we call as hydrogen bonding. So if you have, like, for example, maybe like you ask me, right? If it's HCl, HCl like that, is this two considered as hydrogen bonding? No, this is still van der Waals because chlorine is not electronegative enough to cause a hydrogen bonding. So in this case, no. Okay, so hydrogen bonding only exists between this group over here. Right, give one example of other compound that has the same force of attraction between molecules as compared to S. So it's basically asking you, right, what other molecules can have hydrogen bonding? So the famous one be water, right? We always talk about water, right? H2O. So water is another example. Another one will be, I can explain to you, will be hydrogen fluoride. HF, that one can also exist, hydrogen bonding. Yeah? Right, using the example in question B to explain how the force of attraction between molecules happen. So in a very easy way, they're basically asking you how can hydrogen bonding actually happen. So you can put here that the hydrogen bond forms between hydrogen and a very electronegative element. Okay, so you can see over here. I'm going to write for you. Hydrogen bond can be formed when hydrogen not when, sorry, between hydrogen and a very electronegative element such as fluorine. Right? So it's supposed to be slightly longer some more. So you just put there when the hydrogen atom in HF molecule comes close, continue here, comes close to the fluorine atom, of another HF molecule, a hydrogen bond is formed. Okay, so the question got a little bit too little space, so you can just write it in another piece of paper. I can just squeeze it a little bit. You can read short form if you want to. But in exam, please write full. You can write short form here because you want to save space, but in exam, make sure you write full. Okay, let's take the next one. Does CCl4 have the same force of attraction as compound SY? Okay, for between CCl4, do you notice that there is no hydrogen and there is also no FO or N atoms? It is basically just carbon and chlorine. So in this case, there will be no hydrogen bonding. So you can put here, no. No, because there are no hydrogen atoms. There are no hydrogen atom in CCl4. So that's a short and very easy answer. So by saying no itself, you get one already. And explaining it, there's no hydrogen atom, you basically get another 2 marks. I mean 1 mark. So total you got 2 marks. Okay, right. Next. Diagram 3 shows the part of the periodic table of elements W, X, Y, and Z, which are not actual as symbols of the elements. So based on that, you're supposed to answer the questions. So let's go to the next one. Based on diagram 3, state the force of attraction between atom W. So atom W over here is a noble gas, right? So in a way, I would say that they actually have a very weak force of attraction as well. So in this case, we just have to say that even W itself, although they don't have molecules, but they have atomic size, right? So they are also affected by van der Waals forces. So I would just say here van der Waals forces. All right, explain why atom W does not react with any other elements. So you can just say that because they have the maximum number of valence electron in their outermost shell, and therefore they not react anything else. Okay. Or you can also say that they have already achieved octet electron configuration, also can, doesn't matter. Okay. So in any of these is actually correct. So to maybe save space, you just write that law because atom W has already achieved octet electron configuration. Okay, number 3, cosmetic and medical industries use organic solvents such as alcohols, ethers, and esters because they these compounds are good solvents with high volatility. Suggest the atoms that can react to form the same type of compound as solvent used in cosmetic and medical industry. So what I'm going to try here is just to say is that you can suggest the atoms that can react to form the same type of compound as solvent used in this industry. So we have alcohols, we have ethers, and we have esters. You technically haven't learned this yet because this is supposed to be in Form 5. But the main point here is that they want to know what are the type of compounds that can be used to make this kind of solvents, okay? So I would say that in an easier way, you just have to look into the periodic table. So for example, if you saw this now, right, one of the organic solvent that we can use is this one over here, CCl4. CCl4 is called tetrachloromethane. And it is used as an organic solvent actually. Okay, so in this tetrachloromethane, right, if you notice, right, CCl4, it is formed between chlorine and carbon. And if you see the periodic table over here, it looks very familiar to you. It is actually Y and Z together, right? Because Z is chlorine and Y is carbon. So CCl4 can be formed by Y and Z. So in this case, right, what you're gonna write here is compound formed between Y and Z. So does it necessarily mean that I must pick Y and Z? No, not necessarily. It can be any kind of covalent compound. But unfortunately, right, what happens here is that you can see the periodic table just now. There's only like two combos that you can form covalent compounds, which is only Y and Z, right? You cannot form any compound W and definitely not X because X is a metal. So it comes back to no choice, so only have Y and Z that can react together. That's why the answer is Y and Z. But they give you more options, for example, right? Maybe it can give you more non-metals. The combination can still be different. Not necessarily just Y and Z. Huh? Remember that. So write a chemical formula for this compound. So like I said just now, between Y and Z, we can form something called CCl4, right? But we cannot write CCl4 because we must follow back the same alphabet that they give you. Okay, so in this case, let's see which is carbon. Carbon is Y and Z is chlorine. So your formula should be the same now, XY4. XY4. Hey, is it? Sorry, Y and Z, right? Sorry, Y and Z. My bad. So YZ4. YZ4. That's the formula. You all do know why is YZ4, right? Because like Y is carbon, Z is chlorine. So carbon needs 4 chlorine molecules to share electrons with to achieve octet. That's why the formula is YZ4. I did not write YZ4 because I'm following CCl4. I'm just telling you that it is CCl4 because it is carbon and chlorine. That's it. But the reason why it is the formula is YZ4 is because one carbon atom or one atom of Y requires 4 atoms of Z to share electrons with to achieve octet. That's why the formula is YZ4. Right? Draw the electron arrangement of compound form A and 4. Okay, so a bit hard to draw, but I'll just try my best. Just on our space. So how about we just draw the outer electron arrangement because on our space, right? Let's draw the outermost shell can already. So for Y is carbon. So I'm going to draw like one big circle. And then I'm going to draw other circles around it. Let's draw 4 in total. Okay, so this will be Z, 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 and Z. And then just put like circle for the Y. And then X for Z. Okay, just to show you how they are shared lah. But in exam, please draw full lah, with the two circles inside. Banana space for me, so I draw this one very simple. I will do. Okay, so that should be the answer. Right, all of them share one electron each. Okay, next one. Right, B1 suggests a chemical formula for the compound as a higher boiling point than compound A4. So we have to still use by the same example. So if you want to have a higher boiling point than these two, then you'll be a compound between X, or you can just say X as an element also can. So here you say chemical formula of compound, right? So I would say maybe X, Y is it? X, Z. Okay, X and Z can form a compound, right? Ionic compound. So you put here X, Z. It's an ionic compound. Right, write a chemical equation for the compound form in B1. So if you be very careful with this, if they ask you to write a chemical equation, you must write a complete Valence equation. So in this case, right, when you have this, it will be X plus Z2. Okay, must be Z2. Why Z2? Because Z is belonging to group 17. They are all they are all diatomic molecules. So remember, very importantly, if you have to write any kind of chemical equation that involves any diatomic gas, always remember the 2 at the bottom here. Very important, huh? If not, it'll be wrong already. So X plus Z2, you'll be able to get XZ. But to balance the equation, we're going to put a 2 here and we're going to put 2 here. So this is your balanced chemical equation. Okay. Right, next. Explain why compound B1 has higher boiling point than compound A4, which means explaining why ionic compounds have higher melting and boiling point compared to covalent compounds. So also very easy, just put it over here. Just say that there is a strong, or just put there without comparing, right? Compound XZ has strong ionic bonds, but molecules of XY, or YZ4, YZ4, sorry, and YZ4 are held together, or have, no, sorry, molecules of YZ4 have weak intermolecular force. Yep. So it's a 2 marks question, so you don't have to elaborate too long. I would say if they didn't ask you to explain, unless they ask you to explain, like give you 4 marks in total, then yes, you must elaborate further, saying that okay, compound XZ basically has strong ionic bonds. They are held together by strong electrostatic forces between the ions. Then yes, that'll be 2 marks. And then for YZ4, you can just say that you have a very weak intermolecular force, is easily broken with a small amount of heat. That should give you another 2 marks. But in this case, no. In this case, they just want you to compare the key points only between why compound XZ has a higher melting and boiling point compared to YZ4. So the answer is because one has strong ionic bonds and one has a weak intermolecular force. That's it. Okay, so they get 2 marks very easily for that question. Let's go to the next one. Number 4, diagram 4 shows electron arrangement of water and magnesium oxide. So state a type of bonds for the compounds in diagram 4. So for water, it will be, this is assuming the intramolecular force, not the hydrogen bonding. So for water, it's just covalent bond. And for the magnesium oxide, is ionic bond. Okay. What is the electron arrangement of oxygen atoms? So oxygen is basically 16, 8. So if you look into this, it also has 8 electrons, so it'll be 2, 6. Okay, so that's the electron arrangement for oxygen. And then here, only valence electrons are involved in chemical reactions during formation of H2O and MgO. What is the meaning of valence electron? Yes, correct. Most metal oxides are salts. They are technically ionic compounds as well, because when they donate electrons, then they become ions. So they are stuck together in one. Okay, so yeah, between ionic compounds, they are technically called salts, but we don't really call oxides as salts. We give them as oxides. So we have a special name for anything that has oxygen inside as oxides. Salts are mostly like, for example, a metal and other non-metals like halogen, for example. Those are more referred to salts. But yeah, sure, why not? I would say it's okay to mention them as salts as well. So in this case, what is the meaning of valence electrons? So you can say here electrons in the outermost shell in an atom. Okay. Still number of valence electrons of the magnesium atom. So there'll be 2 valence electrons. And then why do magnesium atom forms a chemical bond? We can just say that because it wants to achieve an octet electron configuration. Or it needs to achieve octet electron configuration. Okay. Then next, you can see over here, each water molecule is made up of 2 hydrogen atoms and 1 oxygen atom. State the force of attraction between the water molecules here. Between water molecules, not within. So if it's between water molecules, it's hydrogen bonding. Hydrogen bonding. And then state 2, physical properties affected by the force of attraction mentioned in D1. So I would say boiling point. Boiling point because basically hydrogen bond is stronger than van der Waals. So yeah, boiling point. Boiling point and solubility. Why solubility? Because hydrogen bonding can determine the solubility of salts and things like that. All right, so that's the two answer, boiling point and solubility. And that's why, like I said last time, right, due to the unequal distribution of electrons inside a water molecule, it creates a partial charge on the oxygen and also water. So we call water as a partial polar molecule. So it can actually disrupt chemical bonds like those in salts, for example, right? So in that way, it can actually sort of like affect how things can be soluble in water as well, right? So last one, give one example of molecule that has the same force of attraction as water. So I would say ammonia. Lah. There are two. Lah. You can either put ammonia as hydrogen bonding, or you can also put hydrogen fluoride. So hydrogen fluoride is also considered as another one that can form hydrogen bonds. So either one. Lah. Okay. All right. So I was trying to finish up the section A with you guys. So section B and C, right? I don't think we have enough time to discuss the answers. But you all can actually try the question on your own. Later on, I'll send you all the answers, then you can check your answers now. Okay, so after this, after we'll be coming for holiday. So next week, no class, remember, next week, no class. I'll be printing out the next chapter soon. So the next chapter is called Acid, Bases, and Salts. So we'll be learning acid and bases in the next chapter already. I would say that we're moving quite fast, actually. Okay, because we are already, we're just hitting May, and we've already finished out 5 major chapters already. 4 actually. Chapter 1 is not available. So yeah, 4 major chapters. Acid, base, and salts will be slightly longer because I want to spend more time there. Remember I told you last time? I told you that it's actually quite tough. So I don't want to rush that whole chapter. So I'm going to take my time in teaching you that chapter itself. And then along the way, if you don't understand anything, you can also ask me questions and things like that. But I'll be printing out the notes soon, most likely by next week. If the center is still open, let you guys know during Raya, I can go pick it up. Okay. Otherwise, we'll wait till after Raya, then I'll pass the notes to you as well. Okay, but I will be posting the soft copy first. So if you want to read it first on your own, also can. No problem. All right. So I think I'll stop here. Any question you want to ask before we go? No. Well, let me take attendance first. Let me take my checks. Okay, no question. I'll see you guys the following week. Okay, take care. Stay safe. All right, welcome. See you.